In the last video, we saw why the Michelson-Morley type experiment cannot detect ether. Now, we will discuss the reactions or events in the universe that release ether to space. Here, the important questions are: what happens to the missing mass in a nuclear reaction? What happens to the missing mass in a collision experiment in a particle accelerator? And what happens to the missing mass in events such as colliding neutron stars, colliding black holes, etc.? Einstein's special theory of relativity suggests that missing matter is converted into energy. According to Einstein, matter and energy are different manifestations of the same thing. One can be converted into the other. Now, let's think about a nuclear fission reaction. We know that in a nuclear reaction, the release of energy appears as high-speed moving particles and the emersion of high-energy photons. A typical fission reaction yields antineutrinos, neutrons, beta particles, alpha particles, daughter nuclei, etc. When these collide with the surrounding particles of matter, it results in the generation of a large amount of heat energy. Since the heat produced is so high, the excited particles emit high-energy photons like X-rays and gamma rays, in addition to other longer wavelength radiations. This provides new insight into how actually a mass defect yields energy. The entire energy associated with a mass defect, in fact, appeared as the kinetic energies of product particles and product fragments, and the collision of them with surrounding matter results in the generation of heat. That is, the missing matter in a nuclear reaction somehow vigorously agitates the products. The interesting thing here is that we are not seeing any matter-energy conversion as special theory suggests. Instead, we see only the missing mass and the high-speed motion of product particles. Here, I reach the conclusion that when a mass defect happens, the missing matter becomes so thin to be detected by any known methods and detonated violently. In other words, the release of energy with a mass defect is because of the change in the state of matter. This provides new insight into how a mass defect releases energy. Now, if this is the case, then every active star in the universe, every celestial collision, for example, colliding black holes, colliding neutron stars, etc., converting ordinary matter into this thin form of matter, and are sources of this type of matter. For centuries, it was believed that there was a substance called ether that filled space. However, Michelson-Morley's experiment failed to detect the ether, and the scientific community began to discredit the ether concept. Now that ether is alive again, we will call it the same ether. Ether is continually produced across the universe. As the ether is a diluted form of matter, an individual particle of ether has every quality of ordinary matter. That is, it has mass, it can be attracted by gravity, etc. This can provide a better understanding of many phenomena in the universe. For example, starlight bending, gravitational lensing, gravitational redshift, time dilation, the precession of the perihelion of Mercury, the precession orbit of S2 star, etc. In the coming videos, we will discuss these phenomena in detail and also how to detect ether. I am Femila Joseph, and thank you for watching.